Hey guys, welcome back to the TUT class. It has been a while I used camera and board relatively. Now, after a series of videos I already listed on my YouTube channel as regards different topics, I decided to look at different textbooks and then see how I could treat some other topics, that are still in the textbooks. And after which I'm going to answer questions on all the topics I've prepared so far on my YouTube channel. Now, for this class, we're looking at elimination. Now, when we say elimination relatively, what do we mean? Now, looking at the question, she said eliminate T from the equation this, eliminate T from the equation this, eliminate L and M from the equation this. Don't mind my brother is flying relatively. I managed to shock it right where it is. Okay, so elimination. Now, when I say elimination, what do we mean? It means we should provide a relationship between what I'm eliminating, and this equation that are on board. Now, such that if I can get that equation and I substitute the equation of T into any of this equation, it will involve only X and Y. What do we mean? Now, let's look at it. For number one question, eliminate T from the equations this. How do I solve the solution? For number one question, we have x equals 80 squared and we have y equals 280. Now, the question that you should ask yourself is, what will I do to either equation 1 or equation 2 to get a relationship between t and either equation 1 or equation 2, such that when I substitute it back into any of these two of them, I will get only x and y involved in the new equation. Now, from equation 2, you can see that y is equals to 280, and from here I can easily represent t. I can easily make this the formula. So you say from y equals 280, what happens? I have what? I have my t to be equals to what? Y over what? 2a. Now, after getting your t to be y over 2a, let's substitute the value of t now into equation 1. Substituting it becomes what? X equals a into y over 2a all squared. Now, this bridge is very strong. Okay, so now this now becomes what? A into what? Y squared over what? Over, expanding this becomes what? 4a. Applying a lot of indices. Now, this is what I'm going to have. By doing this, I can now cancel 4a squared, so 4a squared. So by doing this, I can now cancel one of the a's out. So I have my answer to be what? Y squared over what? Over 4a. It means that my new equation now becomes what? It becomes x equals what? Y squared over what? 4a. Now you can see from this equation that my t is no more what? In play. Now that's for number 1. Number 2 question now. We have what? We have x equals this and y equals this. Now, x has an equation, y has an equation, involving t together. Now, if I say I want to add them together, what happens? If I add them together, this becomes the same denominator. I'm going to have it as t plus t squared all over 1 plus t squared. If I add the equation together. But by doing that, I have not eliminated t yet. Now, what will I do to eliminate t? I need to get an equation where t relatively is involved, which if I substitute into x or y, I can now get the new equation. So let's see. In this case, the best I can do here is what? Say, what is my y over x? Y over x here is the same thing as what? T squared over what? 1 plus t squared divided by what? T over what? 1 plus what? T squared, which is the same thing as what? It's the same thing as what? T squared over 1 plus t squared times 1 plus t squared over what? T. When I do this. Now, what happens? This cancels themselves out. This removes one of these. So I have t. So it means y over x is equals to what? T. Now, t is equals to what? y over x. Now, if I put my t as y over x now, this implies that my t is equal to what? Y over x. If I put my t as y over x now in either equation 1 or equation 2, I'll be able to get what? I'll be able to get the new equation. Okay, so putting the value of my t, which is 1 over x, in either equation 1 or equation 2, it's going to become what? X now becomes t is y over x. I'm going to have that y over x, divided by 1 plus, and then put this a big bracket here, 1 plus what? T squared. That becomes 1 plus y squared over what? X squared. And this now becomes the same thing as what? Y over x times, now that becomes times 1 over this solution. Okay, this solution now becomes what? X squared plus y squared all over x. It now becomes x squared over what? X squared plus what? Plus y squared. Now, so this is what I have here. Y over x equal times what? X squared over what? X squared plus what? Y squared. Cancelling one x out, what remains? My answer now becomes what? My answer now becomes y over what? Xy, I mean, in that case, or yx over x squared plus what? Y squared. Where if x cancel one x here, this remains x times y gives me xy over x squared plus what? Y squared. And this is the answer to this. Okay, so finally now, for number 3 question. Eliminate L and M from the equation Lx plus My equals A, Mx minus Ly equals B, and L squared plus M squared equals 1. And to eliminate L and M. Okay, now looking at this equation, what can we do? First of all, you might want to say, let me equate this together such that I would make this equation 1, equation 2, then find your L, find your M. After we substitute into this third equation, I get your relationship between x and y, which can actually work. But looking at this is Lx, this is Mx, so it's relatively not likely going to work. I'm going to stress yourself getting a long, solution in that case. Now, but the best way to do it, since L squared plus M squared is equals to 1, it means in a solution of this and this, joined together, I should be able to add this, or I should be able to substitute this as 1 in that solution. Now, how could it be? Now, the solution becomes what? Square this solution, square this equation, square this equation, and add them together or subtract them, whichever you do. One of these will cancel out, then we'll be able to substitute this inside